Hello, Professor O'Donoghue here. Today we're going to talk about Boolean expressions and truth tables. So first of all, I have a series of questions that I like to ask when learning about a new topic. That's the best way to learn, is to ask questions. So the first question is, what is a truth table? So a truth table is just a common way of presenting the logical operation of a circuit in a concise table. Okay, so if we look at the truth table that we have right here, okay, it tells us exactly how this circuit should work. There are inputs to the circuit and there is an output to the circuit. The inputs are called A, B, and C, and the output is called X. And what the truth table tells us is that based on the value that we put in for each input, we will get out a specific output. And what we're mainly interested in is what inputs cause an output of 1. If the output of a circuit is 1, we consider the circuit to be true, to be on, the voltage coming out to be high. All of these are synonyms of one another. So when we look at this circuit, we know how it functions based on the truth table. The way it functions is that if input A is a 0 and B is a 1 and C is a 1, then the output of the circuit will be a 1. The circuit will be true. Or if input A is a 1 and input B is a 0 and input C is a 0, then the circuit will be on, or the output will be high or true. That is how this circuit functions. And in order for the circuit to function like that, these are the only two conditions that should make the output go high on the circuit. So that's why whenever you're looking at the functioning of a truth table, every row has to be true. That's why it's called a truth table. All right, let's move on. Product term. What is a product term? So this is the logical product, or the AND function, of two or more input variables. So if we have three variables, once again, as we were saying previously, A, B, and C, and those represent our inputs, if we AND those together, we get a product term. For example, not A, B, C. That's a product term. What about an SOP? What is that? SOP stands for sum of products. Okay, basically it is the logical addition, or the OR function, of two or more product terms. Okay, so we have these product terms and we OR them together, and that is an SOP. An SOP expression is equal to 1 only if at least one of the product terms is equal to 1. So this expression can't be true or a logical 1 unless one of these product terms is true and equal to a logical 1. What is a domain? So just like in algebra, just like in math, the independent variable is your domain. So in digital logic, the input variables are called the domain. Okay? And in this example, we have a domain of 3 variables, remember? A, B, and C. So we have a domain of 3 variables. So how did we find, when we go back to this truth table, how did we know that we needed this many rows? We needed 8 rows, that there were 8 different combinations of inputs. How did we figure that out? Well, to find the number of combinations of your input variables, what you do is raise 2 to the power of the number of domain variables. So in this example, we had 3 variables. So to find the number of combinations, we would raise 2 to the power of 3, and there would be 8 different combinations of input variables. Okay? So that is everything that you need to know about the truth table itself. How do you construct a truth table from a Boolean expression? So if you're given a Boolean expression, how do you construct a truth table? Well, there are 3 steps. One is to list all combinations of variables in the domain. Okay, so that's your truth table right here. So once again, in this situation, we have 3 variables, right? So we're going to have 8 combinations of variables. So we're going to have 8 rows. Okay. Next, step number 2 is to place a 1 in the output column for each binary value that makes the SOP expression true. And then in the output column, you're going to place a 0 for the remaining binary values. So what does that mean? All right, let's look at this sum of products Boolean expression. We have not A, B, C, or A, not B, not C. Okay, how would one of these product terms be equal to a logical 1? That's what we're asking ourselves. What values, what literal value would the input have to be in order for the product term to be equal to 1? Well, we have not A, right? So remember, if you're ANDing, remember, in order for any ANDed variables to be true or to be 1, all variables have to be 1. You have to AND 1 with all inputs being 1 in order to get a 1. Okay, if any of these values are 0, then you AND a 0 with anything and you get a logical 0. So they all would have to be 1s when they're ANDed together. So if you have not A, that's the complement of A, that would mean that A has to have a value of 0, because then when you took the complement of it, it would be 1. Okay, B would have to be 1 and C would have to be 1, right? So then if you ANDed them together, you would get 1 ANDed with 1 ANDed with 1, which is 1. Okay, so if you have all 1s ANDed together, you get a 1. So if we go to our truth table, we're looking for 0, 1, 1. We're looking for the row where A is equal to 0, B is equal to 1, C is equal to 1. We go down to that row, that would be this row right here, and we put a 1 for the output, because that would make the sum of products expression true. Okay, what would it take for the second product term? Well, we have A, we need that to be a 1, right? We have not B. Well, if we need not B to be a 1, then that means B needs to be a 0 to start with, so that when we complement it, it will become a 1. And we have not C. Once again, we need that to be a 0, so that when we complement it, it becomes a 1. Then you would have 1 ANDed with 1, because not B, not 0 is 1, not 0 is 1. You AND all those together, and you get 1. Okay, so now we're looking for the row on the truth table that's 1, 0, 0. We come down here, 1, 0, 0. We put a 1 there. Those are the only 2 conditions that make our circuit true. Okay, so everywhere else for the output, we put a 0. Okay, every other combination of inputs will cause our circuit to be off, or to give us a 0 output. These are the 2 only input combinations that will cause the circuit to be on, or cause the circuit to be true. That's how you complete a truth table from a Boolean expression. All right, what if you're given a truth table, but you need to come up with the expression? How do you do that? There are 2 steps for that. The first step is to list the binary values of the input variables for which the output is 1. Okay? Then you are going to convert the binary term to the corresponding product term by replacing each 1 with the corresponding variable and each 0 with the corresponding complemented variable. Okay? So what does that mean? Okay, that means we look at our truth table. So this time we have 4 variables. So there are 16 rows because 2 to the 14th power means 2 to the 4th power is 16. Okay? So we look at our truth table. We are only concerned with the rows where the output is 1, okay? Because that is what makes the circuit true. So we go to the first row, and the input values would be 1, 1, 0, 1, okay? If you have those input values, 1, 1, 0, 1, your output is a 1. So we write down 1, 1, 0, 1. Now, we have to convert these binary values into variables, okay? So, what did the step say? It says anywhere you have a 1, you put the corresponding variable. So, that's A, right? That's A. So, we would put an A. That's a 1. So, we would put a B. But if you have a 0, you put the complement of the corresponding variable. So, that's input C. We would put not C. And then the 4th binary value is a 1. We would put D. Okay, so this becomes, this row in the truth table has the product term A, B, not C, D. All right, let's see if it's true. If we substitute the binary values back in and then AND them, perform the AND function on them, let's see if the product term is 1. 1 ANDed with 1, ANDed with the complement of 0, which is 1, ANDed with 1 equals 1. So the logical AND output would be a 1 for this combination. So that would make our circuit output high. That's what we want. Okay. We could do the same thing for the next row. Okay. So let's look. We have a 1, so we just write down an A. Okay? We have a 1, so we just write down a B. We have a 1, so we write C. And then for the D input, we have 0, so we write down not D. All right, that's our second product term. Okay? So in order to create our Boolean expression, what we have to do is create a sum of products. We have to take those product terms and OR them together because those are the two conditions that make the output of our circuit true. So our Boolean expression would be A, B, not C, D, or A, B, C, not D. Now we have our Boolean expression from a truth table. Alrighty, that's it for today.